Well, hello and thank you for joining me for another Alex on Tech and ITY TV video interview. I'm joined today by Simon Wistow. He's the co-founder and vice president of strategic initiatives at Fastly. Welcome to the program.
Nice to be here.
Thank you for taking the time. Now, could you please briefly recap Fastly's mission and the value you bring to customers globally in 2026?
So we started off about 15 years ago as a sort of reaction to the current state of content delivery networks, and they were stagnated. All they could really do was cache static content like images or CSS and stuff like that. They couldn't handle dynamically generated content, they couldn't handle APIs, couldn't handle personalized content, couldn't handle long tail content. And just almost out of sheer frustration, we started a company that wanted to sort of basically bring CDNs up to the modern world, like try and drag them forward 15 years. And what we realized when we were kind of doing it was that certain things we needed to do. So, okay, well, if you're going to be caching all the content, including, say, front pages of newspapers and stuff, you need to be able to run some logic at the edge, because you need to be able to make choices about whether somebody is in a paywall or in, some rate limiting and stuff like that. And then we suddenly had that kind of moment of like the flip. Is it an old woman or is it a young woman wearing a hat with a feather, or is it like a vase or two faces kissing? Yeah. It's like, well, if you're going to move some logic, why don't you move more logic? Why don't you move more code out to the edge where it is closer to the user, it is scalable, you don't have to spin up machines and down, it's just there. And if you're going to do that, well, what are you going to do? And the obvious next thing after that was security. Because if you're going to block people, you want to block them as far away from your valuable data. The idea sort of now of like, oh, well, our DDoS protection is a box, a $250,000 box we stick in our data center. And we're going to let the data all the way into we're going to let these attackers all the way into our data center and then block them there. Seems laughably old fashioned. You might as well at that point, like kind of have a lucky horseshoe at the top of the rack or smudge your data center with sage or something to try and keep the bad guys out. And it was like, obviously DDoS, WAF, bot protection, all that kind of stuff. That was the moment where we got really excited, because it's suddenly turned from being, oh, we're making a smart CDN that can do dynamic content, to this is a genuinely different way of doing stuff. And so that was the big mission, was how do we cache and how do we help people protect and speed up and just make their sites better no matter what content they would do. And how do we make that self-service? How do we make it so that it's part of their infrastructure rather than something you have to phone up your account rep and pay 2 hours of professional services at $200 an hour to make any change? You shouldn't have to wait. You should be able to do that all yourself. That was the big mission. And it now seems obvious in retrospect, but at the time there was no CDN out there that could do that. And that was the big revelation.
Yeah, well, I mean, that sounds, as you were saying, logical. And I think, unless I'm mixing my metaphors, the smart people in an organization, the boffins, they're the pointy heads, right? Yeah. But that is so logical. I think you've got pointy ears like Spock, the Vulcans. Oh boy. Okay. So your January Threat Insights report found 49% of all requests were bots. I mean, I've seen it said that, more than 50% of the internet is bots. So this is like very, appropriate figures. And that 99% of those bot requests came from unwanted automation rather than a verified source. So is the industry fighting the wrong bot? And what does your patent pending deception technology do that blocking can't?
So it's different for different industries, by the way, as well. Like some, like publishing and stuff has higher number of bots. I think iGaming has the highest number of people trying to do stuff, and then other industries have less. But we have moved into a bot-first era. We are bot-first web. So there are different types of bots. Like there's the good crawlers. What we would normally you'd think of like Google, the Google bot and things like that. There are the good like LLM models. When I say good, whether you're not that's not a moral judgment. It's about the fact that they identify themselves. They tend to obey things like robots.txt. Yeah. Then there's RAG, the retrieval augmented generation. That's what happens when you type something into ChatGPT, and if it goes off and does something, or Claude or whatever. And then there is sort of this grayer area of companies that are doing scraping and LLM and RAG, but they're not being as good about identifying themselves. They don't have they're not publishing their IP ranges. They're not publishing sticking with a user agent, and they're just spinning up headless Chrome on EC2 and spinning it up and down. And those are very hard to spot. And then there is just good old fashioned fraud. There is the content scrapers, there's the credential stuffers, there's the sort of the ad fraud, all that click fraud and stuff like that. And so it's very big. That's a very big thing. And so are we focusing on the wrong thing? That's it's a bit of a loaded question, because you might sit there and go, well, the AI bots are a very small proportion of the traffic, but you have to treat them slightly differently, which is, in some ways, you kind of don't care about the credential stuffers if you've already cached the content. So you can just basically, it's just cheaper to give them the content. It doesn't really matter. With the AI stuff, you have to run the bot detection for every single request, whether it's cached or not. So suddenly that gets a little more expensive. And the reason why you're doing that is because if you're the publishing industry, it has been a really tough decade. Multiple things happening. I don't need to tell you, but the publishing industry has had a really tough decade, and they are looking at this and wondering, is this the last blow? Is this the thing that's actually going to kill the publishing industry? And so they want to fight back. But the big problem is they don't know what they don't know. This is, and I don't mean that in a bad way, but you need to have the sort of a view of a large proportion of the web to be able to make choices about things. You need to see those kind of global traffic patterns. So that's what we've been doing, the bot report and the specialized stuff that we give to each individual customer. We are letting them know what's going on, because they're in a panic, but they don't actually have the numbers to go and tell their bosses. And then once they've got this data, once we can identify bots, things like residential proxies make it really, really hard to tell if something's a bot. But we can tell, because no normal person would be looking at 5,000 sites simultaneously. So we can spot these patterns, we can give this to our customers, and then they get to make the choice. And there's some people been advocating for microtransactions.
They've been doing that for 20 years now.
Yeah, exactly. That's the thing. It's sounds like a good idea on paper, but there's a reason it hasn't worked. Yeah. Nobody really, I don't think people are really talking about that anymore, but it was a good first step. Let's just say it was a good first step in the conversation. Some people are block everything. Some people are, we'll give you a version of the site, or and some people want to, we'll block everybody except people who've done licensing deals with us. And so there is no one size fits all. And it's what we've been really doing is helping our customers understand what the scope of their problem is, and then work out how they want to respond. Whether that is, like you said, whether that is blocking or these more deceptive techniques. And there are a ton of these, which is basically just trying to change the economics of this. And it's a bit like spam. The big problem with spam was you could send out 5 million emails and it costs you $5. And so you only need one person buying your counterfeit Viagra to make it absolutely worth it. If you can change the economics of that, then suddenly spammers go away, because it's not worth it anymore. They need to buy a lot, get people to buy a lot more Viagra to go and fund it. And so there's some things we could do. So you can block. Then you can do things like tar pitting, which is just slowing down the response in a way that a human wouldn't notice. But for a bot, it's suddenly instead of taking 500 milliseconds to go and do this, it takes them a second and a half. And suddenly you as the bot runner are spending 3 times as much on compute. Okay, well that changes the economics, and it's barely perceptible to a human. But then you can start doing stuff. You can start doing really, really sneaky stuff. You could start doing infinite content mazes. You could start doing proof of work sessions. And so little things that, again, a human probably won't notice, but it's just ups the compute complexity for the bot. You can do really sneaky stuff. And this is where it starts to actually get a little bit you have to check on this. Could you return the content with subtly fake headlines or subtly fake facts? You say, Mickey Mouse has just been, elected, sort of prime minister of the UK. I mean, honestly, with the number of prime ministers we've had recently, it could be anybody. But it's maybe maybe Mickey Mouse is a little too obvious. So some bot would actually notice that. But you could be somebody who is vaguely plausible, has been elected Prime Minister of the UK. Change the number just slightly, change it by 5%, change it by 10%, and then you're poisoning the model, and then suddenly the people who are buying that model or using that model suddenly don't trust it as much. There are problems there with what happens if you change the wrong thing, you change dosage of medicine, or what to do in, sort of something that's really important. What's the emergency number in this particular country or something like that? There's issues with the misinformation, which, we're all worried about in sort of the global area of media. But that's the sort of stuff that you can do, which is just shifting that economics to make it not viable to be a bad crawler.
Yeah, absolutely. Well, it's the honeypot, but on massive amounts of steroids.
Yeah.
And it's fascinating that you can actually go into that level of granularity these are the defensive techniques. It's
that's
amazing.
not even our best ones, but I don't want to give the whole playbook away.
Absolutely. Now, AI traffic grew 6.5 times faster than human traffic between January and May. I mean, and that's after all the previous stories last year of more than 50% bot traffic, etc., that we just spoke about. And 60% of requests reaching origin now come from bots. So that's even more than 50%. So what does that shape tell you about which parts of the web get faster next?
That's a big question, and we could be here for an hour talking about that. But I mean, in a one way, of course, bots are going to go faster than humans. Humans have been using the web for 30 years. We're not, so a lot of people are on the web. It's obviously not going to grow as much. I mean, humans are still growing on the web, which is kind of amazing even after all this time. But the bots are obviously going to grow a lot faster. But what I think the bots do is they examine a lot more of that long tail of content. And that's one of the things, that was one of the problems with the old CDN models, was you had to upload your content to the CDN rather than us pulling from, so what we do, which is pull from the origin. And so that wouldn't work in this case, because it works when, not a lot of people are sort of looking at the long tail of the content, but you really need it now. I think what we've, again, there is no one size fits all answer. We have found some people are like, well, you know what, if they're accessing the long tail, it's not really that big deal for us. Other people are like, well, we keep the long tail on, say, a colder storage or a less performant kind of server. And so, if you're a newspaper, you have the headlines of today are on the super fast servers, and anybody going to the archive gets sort of routed off to this much colder server, which is not as efficient, which is less expensive. It's not, you don't really, it's fine. It's, it's the guest server. That's so we've had people do that. There you go. If it goes to /archives, or if it's, tagged somehow as being like an old piece of content, you still look at www.example.com/article, but actually behind the scenes, it's gone off to something which is, we're not going to spend as much money on it. Or you just block it. So it kind of depends on your use case, like how much you care about your archives, how much you care about sort of bots being able to go back and read them. Because some people do want the bots. It's a bit like the search engine wars of the early 2000s. It's on an easy alliance, but they do recognize that the bots, bots do have some value. And obviously the AI people, so the AI companies do recognize they need somewhere to pull the data from. So there's this kind of slightly uneasy alliance. But yeah, it kind of depends on what type of company you are. And so that's one of the things that we try and do is we don't try and force a prescripted answer on. We try and work with each one of our customers. We're very bespoke for that stuff. We do have standard patterns and stuff like that. But if a customer has unique needs, we'll work with them. And that's what having a really programmable platform means. I think what's really interesting is, we're having this conversation. You said between, January and May, and it's now August. And, if we have this conversation again in 3 months' time, my answers might be different. And that is the part of the problem, is everything is moving so fast that we don't want to tie people down to definitive answers, because what they need might be different from what somebody else needs, but what they need in 3 months' time might be different from what they need now. Yeah. I know that's a very wishy-washy answer, but it's just
the truth.
It depends.
I mean, this is the nuance and the granularity of the modern world. I mean, never before were we able to data mine ourselves with all our wearable devices. Now we can do it, and we don't think twice about it. I mean, it's just there. Your watch is telling you with Samsung your insulin resistance. Your watch is telling you if you've got sleep apnea or if you've got high blood pressure. I mean, you don't have to have these cuffs. I've seen the Huawei watch with a cuff that blows up and it feels like it's cutting your arm off, but then it goes down again, your wrist. And so, I mean, you don't want that sort of technology if there's an easier way. And you guys are using AI as much as everybody else, and just as the other guys are using it to try and get around your defenses, which is why it's such a dynamic and exciting industry to be in.
It is an arms race. The funny thing is, we've been using AI for a while. So internally, things like our image optimization has a smart cropping feature, which detects where faces are and crops the photo to sort of only include so. That's been using AI for, I think, over half a decade now.
Machine learning with
exactly.
Apple. They didn't want to mention AI until the last couple of years.
Yeah,
they were doing it.
Yeah, exactly. And we use it for internally for like looking for anomaly detection, for writing threat rules, but also for routing traffic around. Like we've been using it for a while. This is, if you've been doing computer science for anything more than a decade, you know, sort of the people have been bringing out versions of AI for a while. This is not new in some ways. What is new that this has tipped over a certain point. Yeah. And it's kind of caught, instead of just being a very, very nerdy mathematical technique that only certain people use, it is burst out into the mainstream. Yeah. In the same way that the web did in, say, 98, 99, where it went from being something for, like, the internet went from being something for very deep nerds, and, you know, with AOL and with everything else, it suddenly burst out into the mainstream. And it's like, this period of time feels as sort of very much like the late 90s, and that kind of, we don't know what's going to happen next. Everything seems kind of weird. There's a lot of overblown stuff, but it's really, really exciting. But
it's also the difference between things being deterministic, the algorithms that came up with reliable, the same results each time, through to things being probabilistic and generative. Yeah. I mean, that's the big shift, and that's where you get that fuzzy logic that allows it to come up with stuff that you didn't expect, which was like, oh, that's a connection we never thought of before.
Oh, we could go deep into fuzzy logic and vector space analysis and contextual network graphs and stuff like that. All right, we could that, but then we'd be here for another 2 hours.
That's it. Well, we're already going quite deep, which is good. Now, Akamai has put NVIDIA Blackwell GPUs across 4,400 edge locations, which is pretty amazing when you think a little edge server is meant to be this little simple thing, and they're these Blackwell GPUs sitting there. And Fastly's chief financial officer, Rich Wong, says you're not in the business of what we would describe as building a neo cloud. So what's the positive case for a CPU first edge? Something that AMD spoke about at its recent launch, saying, look, it's not all about GPU, it's about CPU too. What does the customer get today from that choice?
So we're about to get real nerdy. So in previous life, I had to do graphics programming. I did visual effects. I did games. So I've done GPU stuff. So I have a lot of opinions on this. Akamai have a very particular architecture, and a lot of their architecture stems from the fact that when they started in 1998, the internet was a very different place.
Very primitive compared to today.
Yeah, exactly. And so, you know, their architecture is based on a certain way of thinking. One of the reasons why we were able to get started was because we realized you don't need that many pops. You can co-locate stuff next to internet backbones and make each pop fewer pops, but much, much bigger, because the latency between your house and an internet backbone is now quite short.
Many of us are on fiber.
Yeah, exactly, yeah.
Not dial-up anymore.
Whereas when Akamai started off, it was 28.8K modems, maybe 56K had just come out. It was local ISPs, things like that. And so the metaphor that I use, or I've used in the past, is when Akamai started off, the roads were terrible, and if you wanted to go and buy something, you had to go to a corner shop that was just around the corner from your house. And the shop was very small, and it had the few most important things. It had milk, it had coffee, it had tea.
And at expensive prices.
Yeah. By the time we started, the roads had got good, so you can drive to the supermarket that's on the edge of town, and there's a lot more stuff. But that would be a problem, because the supermarket's a lot bigger, so it takes you a lot more time to go around. And that's where SSDs came in. And SSDs, if you think of them as dollars per gigabyte, are really expensive. If you think of them as dollars per IOPS, which in and out operation per second, they're really cheap. And that meant that, you know, you could pull up to the out-of-town supermarket, and then your shopping would already be waiting for you. And so that was the things that allowed us to get started. So their architecture is very different. So I don't want to speak to what they're doing, but you would think, because we have fewer, more powerful pops, we'd be great to do GPUs in. Great, we'll go do that. Except it doesn't really make any sense. GPUs are incredibly expensive to buy. They are very expensive to run. They're very power hungry. And because they're power hungry, they run really hot. And you need to cool them down. And so they're really expensive. But also, they are slow to load data onto. Like, when I was doing stuff 20 years ago, it took about 30 seconds. And now, 20 years later, it takes about 30 seconds because they've got bigger. And that doesn't work with... We're called Fastly. We can't return your web page after 30 seconds. It needs to be like milliseconds. And so But also, GPUs are not designed to be multi-tenant. Like, when I was the only person programming a GPU, it was difficult enough. You're writing, the whole point about a GPU is you write one thing, it goes off in parallel and does thousands of operations in parallel. That's difficult, like getting your head around that. And we would screw up all the time. And then, the walls of the company, the film company, we had all these kind of glitch art, all these accidentally kind of weirdly beautiful problems. That is a potential disaster for security. And what do you get out of that? Like, okay, well, now we're running the inference, that GPU inference on these massive models at the edge. It's taken 30 seconds. It's really expensive. We're going to have to charge you more. Big potential security risk. And you've shaved 500 milliseconds a second off a query that takes 8 seconds. Like, I'm not sure, there's an American phrase, the juice isn't worth the squeeze. But that's not to say inference at the edge doesn't have some points. We do inference at the edge. We use it for our AI accelerator, which is the semantic cache. Like I said, we use it for smart cropping. I think it makes much more sense when you have just a different twist. Like, what are the applications you need lower latency for? So voice. We as humans are really, really susceptible to, if there's a lag in voice stuff, it comes across as not human. It triggers our like kind of uncanny valley reflex.
That's exactly the word I was thinking of.
Yeah, exactly. And so, okay, I can imagine. If I'm going to make a prediction, and it's really hard to make a prediction, I think we are going to have some giant mega models, the frontier models. But I think also people are going to start doing smaller, more specialized models, whether that's distilled from bigger models, whether that's specially trained. If you are McDonald's, McDonald's were using, I think, ChatGPT as their sort of help desk, and people realize, well, why should I burn through my ChatGPT tokens when I can just put my programming question into the McDonald's chat and it will write my Python script for me. And so I think McDonald's will probably, if they haven't already done it, move to a smaller model. Smaller models, much easier to run on the edge, and you can run them on the CPU because they're just not as big. I think also we're going to start seeing more dedicated hardware, which is much better for running inference at the edge. So things like, people have been talking about TPUs, whether that is they have memory managers, they have like kind of multi-tenancy features, or it's just dozens of small chips and you can just run stuff on them and it's quick. I don't know how that's going to go. We do inference at the edge. We have customers who want to do inference at the edge, but most of the time, the idea of running it like an H100 or something like that at the edge just doesn't really make sense. Maybe Akamai have a very different reason. Like, I can't speak to their internals, but for us, it just doesn't make sense.
Yeah. And the future is offline AI running locally on, your CPU, or you've got a GPU, but it's running without having to go back to the cloud somewhere else, which adds extra latency.
Yeah, exactly. I mean, that's what we don't know. I can only tell you now that the cost and the risk doesn't make running GPUs, like us going and putting 5 H100s in every single one of our sort of machines in every single data center would be a massive capital outlay, and I just do not think it would be worth it.
Yeah. Well, I mean, I'm running local AI on my phone and my computer, and it works. I know people are running Olama, and some of these are using GPUs, but it's just obvious, like the centralization and decentralization. And for years with your iPhone, if you wanted something to be converted from voice to text, you had to go to the cloud and come back. But now you can put your phone in plane mode and transcribe text all day long.
And that is, I think, the perfect example. Like, we run an edge computing service. Do we think everything should run on the edge? No, obviously not. There's loads of stuff that should run on the central clouds. Why we work with all the central clouds. We partner with them, and now we've got incredibly powerful, like, your phone is faster than every single computer on earth was in the 1960s. Like, we have hypercomputers in our pocket. What's interesting is you said you had that voice to text, like kind of transcription, and it used to go to the cloud. And then at some point, unless you were paying attention to the Apple release notes, it changed and it went up, and you didn't notice. Maybe things got a little bit better, but you probably didn't notice. And that's the way it should be. People need to run workloads. And if it needs to run on a client, great. If it needs to run on the edge, great. If it needs to run on a central cloud, great. If it needs to run partially on like public clouds and then partially on a GPU farm that's running out of Iceland.
Hybrid.
Hybrid stuff, great. you as the consumer, you as the user definitely shouldn't know about it. And we should be helping our customers architect things so that it works best now. And then when things change in the future, they can change it and their users will never notice things. And that's what you asked what our mission was. Our mission is making hard things possible and making things easy for our customers so they can get on with being the best at what they're doing, and we'll handle all the delivery stuff for them.
Yeah. It's said that a technology succeeds when it becomes invisible. Yep. Nobody thinks about turning on the light switch or the water and light not coming on and the water not coming out. It's only when it doesn't work that something, what's going on?
Well, this is the funny thing about running a massive global network, is we are so used now that the internet is all pervasive. Through 5G, through Wi-Fi, it saturates the ether. And we complain, I can't stream 4K video when I'm at 30,000 feet in the air, screaming over the Pacific. Yeah. We have come so used to that. One of the things about running a giant global network is you suddenly become aware of the physicality of the internet. You got some backhoe in Idaho, and suddenly half your transit across the US is gone. Like a shark eats a cable in just off the coast of Japan. Okay, well that's suddenly we've got to route stuff around there. People put up bad BGP routes. We can track things like plate tectonic drift over the last 15 years. We can tell when continents are getting further away because our ping times go up. We've tracked hurricanes up the East Coast of the US because we can see when the traffic dips and stuff like that. It's like you become acutely aware of the physicality of the internet, which is kind of cool. It's like it feels like yeah, exactly. It feels like you've got the secret, everybody else, but I know how it really works.
So Simon, the Skyfire partnership verifies AI agents at the edge using tokenized know your customer credentials and clears payment in milliseconds. So which Australian use case reaches production first, and how much work is it to switch on?
So Skyfire's, we've been partnering with Skyfire for a while, and I think for Australian First Sky, I think it's mostly they are focusing on publishers at the moment. So there are a lot of very august newspaper and publications in Australia. It's a very rich media culture. They are going to benefit from that, and it's really easy to turn on. Customers do it super quickly. We usually don't need to be involved, but we're there if they need to get involved. But it just gives them a few more options. We have a bot product, but we are also acutely aware that everything is moving so fast that there are going to be other people out there who have area of expertise. And so it behooves us to do the best thing for our customer, to partner with these people to make it as easy as possible. And so at the moment, I think it's the best people, the people are going to get the most out of it with the publications, but we can very quickly start saying, it's going to be media streamers, it's going to be e-commerce sites are going to have the same problem. All the problems the publishers are having at the moment, I think the e-commerce sites are going to have in the next 12 to 18 months as they start dealing with agentic payments and stuff. So that's the people who can benefit.
Yeah. And speaking of media streamers, your La Liga system spots illegal streams live against a Grant Thornton finding that 81% of 10.8 million unauthorized retransmissions in 2024 were never taken down at all. So what would it take to point that at the NRL, the National Rugby League in Australia, the AFL, our football league, or Foxtel, our pay TV company?
So there's a bunch of techniques we use to try and spot pirated streams, and obviously we can't talk too much about them because then it's easy to. And so La Liga came to us because they were having a problem where, there were other companies who were hosting pirated streams, and it was difficult to work with them. And so there was a very high-profile court case. There were entire net blocks being cut off in Spain. The same thing was happening in Brazil. It was happening in Italy. And so they came to us and said, we look like the bad guys. We would like to have a better, better method to this. And so we were looking for much more precision strikes. And so we try and spot illegal streams using a variety of different techniques, one of which is looking for content that looks like a football match or looks like and that's been really successful. And it reduces it reduces costs for us, it reduces costs of the league, it takes down piracy. Piracy, I think globally, it was some ridiculous amount of money, huge sums of money. And so if the NRL are getting into that, they come and talk to us and we start working out what the patterns are. We know for a soccer match, it's 90 minutes plus halftime plus extra time. So we can start looking for characteristics around that. Rugby match is different. It's 80 minutes. Like, doesn't have quite the same like level of overtime and stoppage time. That sort of same thing with basketball. Same thing with like NFL games go on for hours, even though they're only 60 minutes. It's a pattern. So what we would do is work with them to go and try and find these things, and whether there are any other techniques as well, because you've got to come at it from a multi-pronged approach.
So Simon, Fastly Executive Vice President of Strategy and Operations, Nick Rockwell, wrote after the June 2021 outage that we should have anticipated it. So what got built afterwards, so one valid config change, can't do that again?
Yeah, so that was not our greatest day. And what was interesting was like a lot of CDNs around the time. Akamai had an outage very close by, and so did Cloudflare, to the point where people were worried that this was evidence of some sort of attack. It wasn't in our case. It was a genuine bug, and the bug had been in place for months. It's just this particular conditions triggered it. Yeah. So what we kind of we took a step back and said, and actually all our systems worked pretty well. We identified what the problematic issue was, I think within minutes. And then we very deliberately did a slow roll, because when you're doing disaster recovery, rushing things tends to make things worse. But we took a big step back and like, how do we prevent this from happening again? And it's a bit like any kind of like anything you do with security, like you can protect against this class of attacks again. Anybody tells you there will never be bugs again in any code is dreaming. But we can have a look and go, well, how do we mitigate the effects of there being a bug? And so what we did was make it so that if one thing we increased isolation, so that different customers were isolated in a lot more concrete way. This was one of the reasons why we've been playing with WASM and why we've been part of the WASM Alliance, the Bytecode Alliance, because WASM has very strong isolation. And so we accelerated that, we made that sort of a big part of our system. But we also made it so that if one particular customer starts triggering a bug, we can disable that customer and not anybody else. It sucks for the customer, but they would be down if we were completely down. So we can isolate the problem just to this one customer. And we also made it so that we can roll back to a known good version really, really quickly. And so, some of this stuff seems fairly obvious in retrospect, but you kind of have to deal with whatever's happening and then come up with like, how do you stop this happening again?
So your report found software bugs triggered 40% of incidents last year, speaking of software bugs, overtaking external attackers at 39% for the first time, while 90% of developers now use AI assistants, like we all do. So the briefing says Fastly assesses AI written code before it ships. So what has that pipeline already caught?
So the days of me knowing every line of code in the system are long gone. So I don't know. I can't speak specifically for other developers. I know for me that it is found like subtle bugs that you wouldn't necessarily notice, especially in cases where, you've missed this use case, or one of the things, the new models are really good, where they have very long context windows or technologies that kind of simulate long context windows, which is one of the things that Fable is really good at, okay, well, if this happened, and then this happened, and then this happened, and they're all really rare, but if they happen to happen, that would, this would trigger something. And that's been really useful. Yeah. We are also, there are more modern languages than C that protect against a class of us. We use a lot of Rust, we use a lot of Go. They protect against certain types of things. Rust has the borrow checker. Go is much safer language. And so that eliminates a whole class of problems. What's interesting though is that it's not that bugs have got worse. You said that bugs are now causing more problems than bots. It's not necessarily that we've got more bugs. It's just we got way better at blocking bots. So it's a positive thing, not a negative thing. But I think we're just doing what every software shop, which is how to use the tools to go and reduce a class of problems you've already seen before. You can never fully eliminate bugs, like whether that is subtle bugs or like kind of logic problems or something like that. You just have to have a framework to make it so that you can find them. You have eyes on, you have automated code reviews, you have sanity checkers, you use ASAN and other things and fuzzing. We use a lot of fuzzing, and we just try and use more and more techniques to go and find the bugs. And that's the best you can do.
A friend of mine is PR and marketing. And he had some developers write some code from 3 or 4 years ago, and he's obviously now using Claude Code to review this. And it's like, oh, the developer took some shortcuts here, wasn't very efficient. That actually looks like some sort of malware that's been there for a couple of years. And it's like basically the output is so much more accurate. I mean, we've heard of Mythos and the latest Fable 5 and the things from OpenAI. I mean, we should be far more efficient and producing much better code, and we just got to watch out for the AI slop sort of code that we should be getting much less of.
I'm from a generation of programmers that, especially when I was doing games programming stuff, I would check the output of the compiler to see if it was efficient and there weren't any bugs in it. So I've lived through that. Now I don't do that. Compilers have got so good. I have written code with coding agents that have had subtle security bugs in. And the reason why I can spot there were subtle security bugs is I made them when I was a junior programmer.
You have the experience.
Yeah, exactly. So we all, AI coding agents can be extraordinarily productive. They can be incredibly diligent about adversarially checking all your code and finding bugs. But they are also going to make mistakes. So we also have humans, but humans can make mistakes. You just have to have defensive depth.
Yeah. Well, I mean, this also reminds me, it was said that, to err is human, but to stuff up takes a computer. But in the modern era, to really stuff up takes a computer with AI.
Yeah. A lot of you can stuff up and spend a lot of money on tokens.
Yeah. Object storage added an Australian region, AU East 1, in February. So what can a customer guarantee stays onshore today, and what certification comes next for government buyers? The whole sovereignty question, obviously.
Yeah, so sovereignty has become one of the biggest questions we've had from a lot of our customers. So we have people like gov.uk, the UK government kind of website, and they were one of the first people that really looked to us for, okay, well, we need to keep all data within the UK. Europe was the next big place because of GDPR. Anybody coming into one of our European POPs or who is otherwise identified as being European, we want to keep them only within Europe. And the nice thing is, it's super easy to do on our platform because you just say, if user is European, then only use European POPs. I know that sounds kind of ridiculous, but that's the whole point about having a programmable software-defined network is that stuff becomes ridiculously easy. And so what happens is as more and more people start looking at sovereignty, okay, well now we've had a bunch of Australian companies who want to do that. Okay, well let's fire up an Australian kind of object storage reason.
The demand is there.
Yeah, exactly. So, and it just becomes just another place you go and do that. And so, we have a ton of certifications. We've got PCIe, we've got Gov, the UK Gov one. We've got some medical ones. HIPAA.
So many of these compliance.
SOC 2.
Yeah.
I think we're looking at other ones in the US. We're looking at ones in other countries. If a company comes to us and says, "Hey, we need this," the thing is, at a certain point, actually, we've probably done all the work. It's just filling out the paperwork. Yeah. I'm not to disrate our compliance team are incredible, and there's always other things, but they have done such a good job that most of the time when we get asked a question, "Oh, do you do this? Do you do this? Do you do this?" It's like, yes, we're already doing that because it's both good programming practice and we've had to do it for other compliance. So I don't know off the top of my head exactly what other compliance things we're doing. But
if someone wants to know, they can ask your
Yeah, exactly. Yeah.
No problem. Now, AI first firms here take 100 extra days to recover against 80 globally, and AI scraping costs 75% of local organisations an average of Australian $595,000 a year. So how much of that gap is simply Australia and New Zealand adopting AI earlier and harder?
It's tough to know, honestly. Yeah. I think as a technology region, Australia and New Zealand are kind of unique in the fact that they're sort of, it's almost like it's like the way the wildlife evolved in Australia was in its own unique way and very kind of cut off from everything else. So the technology firms here are amazing, and
we've always been early adopters here.
Yeah, exactly.
Always.
So
American companies would test stuff in South Australia.
Yeah, I mean this is one of our fastest growing regions, and we have been just what companies are doing here, and actually, to be honest, how close knit the community is, especially within specific industries like media, but honestly across the whole technology, is it really thrives a sense of community and people pushing each other forward. So I can't tell you exactly why, one thing is, you had some numbers and when we were talking about this earlier, you had some numbers, but there's an exchange rate, so they could just be an exchange rate kind of issue. But I think the fact that the companies here are so innovative and are trying to push things forward and really kind of push against each other probably is leading to some of that. It could be a whole bunch of other reasons. Like it could just be because of the sort of concentration of people and the way that makes it easier for, it makes it much harder to kind of detect where bots are, because data centers are very close to the centers of population and lots of people have like residential proxies and things like that. It could just be because, so many people have broadband and are, sort of do streaming video. Like streaming video here is much more widely adopted. It is, sort of hugely popular. So there's a whole bunch of reasons. I can speculate, but like I don't want to say a definitive answer.
Sure. So Simon, AI content transactions through your monetization partner Tollbit grew 32 times during 2025, with hundreds of publishers now taking payouts. I got to find out about Tollbit. Yeah. So what does that look like?
Super interesting, really, really smart people.
Yeah, for sure. Now, so what does that look like for a mid-sized Australian publisher, and where does Content Guard fit for people protecting cached content?
So it's been a really, really interesting year. There's been a lot of noise about kind of publishers and sort of how it's affecting them. A lot of people kind of panicking, and a lot of people kind of looking to see what is the best practice. And you get these emerging best practices. Like, there has been no standard that has come out that has really has 100%. It's not the definitive standard yet. People are still trying to figure out what's going on. Tollbit really, really helps with that. You can take the sort of nuke all approach and like, we're blocking everybody except people who pay us. What we have heard from a lot of people is they don't want to do microtransactions. That the infrastructure for that is too much of a pain. It's too complex and stuff like that. What we have tended to find is that people are doing either licensing deals, where we will block everybody but AI company X because they are paying us a certain amount a month or a certain amount a year, or we have found that people have done agreements where we will return the content in a way that makes it easier for the LLM to ingest, and in return you are going to do what's called grounding, which is instead of just saying this is true, it says according to blah blah publication, this is true, and also preserving things like affiliate links and stuff that can still make money. No one approach fits every single publisher. What we are starting here though is, if you think of every single mid-sized publisher around the world and every single agent, sort of company, it is impractical for every single one of those publications to negotiate with every single one of those LLMs, companies, and vice versa. That is just not sustainable. And the LLM companies are going through hypergrowth. Which makes everything very disorganized, because if your company is doubling every 3 months, like who's in charge of that? Things may stabilize and things might come into sort of more of a manageable way of doing this, but it's not entirely clear. And so that's why we're kind of working with a bunch of different, we're working with the IAB, which is the Interactive Advertising Bureau, working with Spur in the UK, which is a coalition of publishers, Ozone, which is another coalition of publishers, working with the IETF, all these kind of different standards. And we work with our customers to try and get them in contact with the AI companies and also to just do whatever they want. What might work, and this is very much a might, is something more like ASCAP. So ASCAP is the American Society for Composers and Performers. I think it's basically what happens is, if you want to use music in your movie or on radio or something, you pay into ASCAP, and all the members of ASCAP basically then get paid out by ASCAP. It helps that ASCAP is a union, or it's part, it's kind of affiliated with the union, so that has this level of organization. Will that happen for publishers? Could that be a way of doing? I don't know. We have seen companies which are basically doing big, you go and sign with them as almost an agency, and then they go and negotiate with the LLMs to go and do these things. So they're kind of almost acting as a private version of that. That, I think, is probably going to be the way that it goes forward. Is everybody going to be happy with that? No. But there's, you're running into fundamental problems, which is how much is this content worth? Like, is the Sydney Morning Herald worth X amount and then The Age is worth another amount? But what about Bob's fishing blog, which is probably not valuable to a lot of people, but to a small group of people, it might be very valuable. Like, you suddenly get into this question of how do you value content? And that's above my pay grade, but we can provide the technology that gives people the options to go and do that.
Certainly, these are things that you didn't think of when you first started Fastly.
No, I was a low-level nerd. I did not think I would be sort of lobbying to governments about the sort of protection of likeness rights and things like that. So,
yeah. Now, half of AI-first businesses can't say who owns incident response against 23% everywhere else, yet 79% still land the blame on the CISO. So who should own it, and how does Fastly handle that internally?
We actually we got really lucky. Through a series of strange events, we actually know a lot of first responders. One of our first investors is a guy called Jesse Robbins, who was he's a VC, but he also was one of the leading lights of the DevOps community, but he's also a firefighter, and for a while, he was the chief fire marshal of BlackRock City Fire Department, which is the fire department at Burning Man. Oh. So actually, there is an O'Reilly book on incident management, which comes from an event that Jesse put together with me and Arthur, my co-founder, and a bunch of other people, the great and good of the, sort of head of DevOps at Twitter, head of DevOps at Amazon. We got together for a day trying to see if we could learn anything from the first responders and whether they could learn anything from us. And it turns out they could learn nothing from us, but we could learn a lot from them. And this was really early on in Fastly's history. So we have actually had a really robust incident response. And the book, by the way, is great. The O'Reilly book on incident management is a really, really good read. I think we were lucky to do that. I think for a lot of people, they don't know what they need to do for incident response. There is, it's a basic playbook, but then there's a very advanced playbook, and people have heard little bits of it. Oh, no blame culture. Oh, write everything down. Appoint an incident commander. But there's a bunch of stuff. It is a skill, and you have to practice it, and you have to do war games and sort of practice drills and surprise it on people. But there's loads of tiny little things that you don't realize. Like, if you think this is going to be a long outage, send half your people home now, because at some point the current people are going to get tired and you need people who are fresher coming in. Like, there was when we were doing this, like, kind of this workshop really early on, I remember one of the first responders was telling me about how he'd been called to a thing where a horse had fallen down a sinkhole that suddenly opened up. And so there is nothing in the Marin County Firefighters Handbook about lifting horses out of holes. Like, it's just not, because you cannot document everything. Mm. But he knew, well, I'm going to be lifting something heavy out of a hole, so let's get somebody with a crane. I don't want the horse freaking out because people are looking at it, so let's get some screens, and we're probably going to need a vet. For one way or another, we're probably going to need a vet. And so I think that's part of the training, is when you come across a situation you've never met before, how do you break it down into stuff that you can actually respond to so you can learn about it? And so it doesn't surprise me that a lot of companies don't have an incident response kind of team. Sometimes it is the CISO. Sometimes we have a dedicated incident team, but we train everybody up as incident commanders. And the person who might be running the incident commander, might not be the highest ranking person in the room. It might be the person who has the best knowledge, or even the person who just discovered it. But everybody understands what happens in an incident, and that what the hierarchy is and what the method of doing stuff. We don't question that. And then we have a very rigorous thing afterwards, which is, what have we learned from this? And so it's a discipline. I think go read the book, not least because I mentioned in it, and go practice and just read. And there's a bunch of companies out there, Incident.io, and that will kind of help with this kind of stuff. But yeah, it doesn't surprise me, like, if AI first companies are moving so fast, because that's the best time to use AI, is really, really early on, when, sort of you're moving, like that very dynamic period at the start of a company. It doesn't surprise me that therefore it's kind of, they're, very small companies that are moving very fast. It doesn't surprise me that they are going to be overrepresented as not having like really good incident response.
Now, you've written that Fastly prefers to work with an open standards process rather than proposing similar but proprietary mechanisms. So while Cloudflare starts default blocking mixed-use crawlers on the 15th of September, what does the win for RSL look like in a year?
I am a big open source person. I think Arthur was a big open source. We met doing Perl, so that's how old school we're doing. And we firmly believe that the internet is based on open standards. And that it is better when everybody can interoperate. I mean, this is just the way the internet's worked. And to be clear, like there are some really great people working on standards at Cloudflare. Like Mark Nottingham, who actually lives in Australia, has done everything from HTTP2 and HTTP3 and a bunch of stuff, and he works at Cloudflare. I think the advantage that there was a bunch of standards that were being worked on for content blocking, and Cloudflare were definitely part of that. And then they did this big announcement. I think what they were trying to do was galvanize, I think charitably what they were trying to do was galvanize the industry. And it did, it got everything moving. So, you know, that's the upside. And sometimes we get things where people come up with a de facto standard and it gets adopted by everybody. So MCP was this thing that got done by Anthropic, and is it the best remote procedure call sort of standard ever? No, but it worked well enough that everybody started to adopt it, and now we get the sort of the stateless version. Sometimes just the de facto standard is good enough. The Cloudflare standard was close enough to RSL and a couple of the other ones that, you know, sort of interoperability isn't that hard. I do think it's better when everybody's working on, because like, especially at this point, nobody's quite sure which standard is going to be. So it's better if everybody rallies behind a standard and everybody can get on the same page. That's going to encourage adoption. You know, there's always a joke, which is there were 5 standards, we decided to unify them. Now there are 6 standards. Yeah. But yeah, we much prefer to work with a community process. The downside of that is that sometimes that takes a long time. And if people are really looking for a solution quickly, maybe that isn't the best thing. So we try and be flexible.
When you were talking about those standards, I had the XKCD comic in my mind about the 15 standards, but now there are 16 standards.
Yeah, exactly. Yeah. I try not to mention XKCD too many times in the interview, but there's a good comic for everything.
That's right. I was so cool that you said that, because that was the exact thought going in my mind. Now, Fastly's own bio says you worked as a cowboy in Australia, mostly because it seemed like a good idea at the time, which, here, hold my beer, you know, watch this. So which of the bartendering, the cowboy work, or the visual effects turned out to be the best training for running infrastructure at this scale? Because you did some Harry Potter stuff too.
I did it, yeah. I worked on so the reason why I worked up in 16,000 acre sheep and cattle station up by sort of Nundle, Tamworth area. Yeah. Country and western capital of Australia.
I've got friends that live in Nundle.
Yep.
And I go and visit them every now and then, and they've got cows.
Yep, it's beautiful up there.
Yeah.
I was in Sydney during the Olympics. I was backpacking around the dot-com crash. I used my ill-gotten gains from the dot-com boom and went backpacking, ended up in Sydney during the Olympics, was living in the YHA above Central Station. And it turned out to be really expensive, and I needed to go and earn some money. So I heard about this cattle station where they would go and they would hire people. So went up there, worked as a farmhand for a bit, and then kind of ended up working as a cowboy. And it was great. Was it useful for running large-scale networks? Probably not, although looking after sheep and cattle did train me to
big.
Well, using cattle prods really helped me look after teams of engineers. The VFX, I worked in VFX in London sort of just as the VFX explosion happened. So I worked on, joined the end of the Harry Potter 2 movie, and then 3, 4, 5, and 6. I worked on Wallace and Gromit, I worked on Troy, Kingdom of Heaven, a bunch of stuff like that, doing what's called procedural effects. So procedural effects are things where you don't want to animate by hand, but you know, sort of like you need them to be simulated. So that's things like Whomping Willows, or the fur on werewolves, and you know, sort of animagus dogs, and chocolate rivers, and big crowds of like kind of armies running towards each other, and swarms of bats and things like that. So all those things that you want to be doing that. All these things you simulate. And so we were running, I think at the time our rendering farm was one of the top 1,000, but maybe even top 100 like supercomputers in the world. We had a big rendering farm, And so what I learned was the faster that we can make this system, if you can find all the inefficiencies and you can cut a rendering time down from 8 hours down to an hour, well, that means that we can render 8 different things in the same time, which means we can experiment a little bit more. We can try different techniques. We can try, does this look cool or does this look cool? So learning how to be efficient gave us more freedom to be creative. But it also taught me that being creative is fun, and like that being technically correct is not as useful as being how people perceive you. Like, you know, we did the Chocolate River and it was fast flowing and gloopy, and fluids can't be fast flowing and gloopy, but that's what the director wanted. So we figured out a way to do it, and he was right. It looked better. So even though technically correct wouldn't have looked like that, emotionally correct. And so what's interesting about that is, you know, people talk about, you know, sort of AI tools making coding easier. I think it's interesting we've not seen any medium or large scale companies say, well, we've kept all our programmers, we're just shipping twice as fast. Because it turns out a large company, the code was probably not the only bottleneck. But if you can make coding easier, you make experiments cheaper. And that means you can try a bunch of little cool things, or you can try different techniques. And then, so even if you're not shipping twice as fast, you're probably shipping twice as well. And so so I would say the VFX taught me how to do stuff really, you know, really scalably and really, really fast, and also how to make the best user experience, whatever that is going to be. It also taught me about deadlines, because there is no, as I would walk from the tube station in London to my office, I would see posters for the movies I was working on. It was like coming out September the 15th. And suddenly you're like, well, that's a pretty hard deadline. You know, there's no way I can turn around, you know, we don't get to turn around to the director. And we're like, oh, sorry, we didn't get it shipped. Can you push them? Can you print up new posters? Like, it really taught me about this is the hard deadline. And if we don't think we're going to make it, we're going to have to make some hard choices about how things and like how to be economical about stuff. So that's another skill that I would kind of really appreciate that I learned from that industry.
So before I ask you a couple of fun personal questions and for your final message, we've covered so much today, but is there anything else about Fastly that we need to know that you haven't already had a chance to talk about?
Well, we covered a lot. I think one of the things that's really interesting is, you know, when we started off 15 years ago, we were trying to solve a particular problem, and as the internet has evolved a lot in the last 15 years. And what's been really interesting is, because of the flexibility of our platform, we have adapted with that time. 15 years ago, people thought, well, everybody was just going to be with one cloud provider. Maybe if you're a, you know, real data, you might have multiple regions. That is not what we've seen. People have multi-region, multi-cloud. They've got hybrid. They're stitching together third-party platforms. Any combination of architecture that you could talk about, we have seen.
Anything and everything.
Yeah. And stuff is evolving again. Like, streaming media has changed the internet. It's, you know, sort of videos are 4 times as big because they're twice as big in both directions, and it's no longer everybody sitting on a couch in front of the TV. Somebody's watching on the Apple TV. Somebody else is watching on the, you know, the smart Samsung TV.
Someone's
and the other
on the phone, on the train, on the plane, the car, everything.
Yeah, exactly. So we've had to, you know, sort of more and more events are now watches streaming, like, you know, to the Olympics, the World Cup, you know, sort of the Super Bowl, NRL, everything. We were just talking to some of our customers because they are streaming kids' cricket games because it's so cheap now to go and do it. So like, kids are, you can watch your kids' cricket game as if it was a multi-camera sports setup. That's amazing. I love that. I love the democratization about it. I love the fact that it's much easier to consume content. That has changed the way that we're doing content. The internet has changed. Like, even some of the biggest streaming companies in the world have problems streaming live events. And it's not because the people there are dumb or not good at their job. It's just really hard. And so what I love is the fact that the internet is still changing. I have been doing internet stuff since the mid-90s, and I am still learning stuff. It's still cool. This is a very, very exciting time. And we are having to adapt, and we are finding new architectures. We're embedding POPs within telcos and broadcast companies. We're doing all kinds of crazy stuff like for the next year. This could be another 2-hour conversation talking about that, but it's a really, really exciting time. And AI, the other thing I think is really cool is like AI has the power to potentially democratize the web. I think the web is better when it has more diverse and varied voices on it. And the more that people can go and it's great that people can go build stuff, but then where do they go deploy it? And how do they protect themselves from, an average site now could get DDoS by a DDoS attack that would have made Google blush 20 years ago. And so how does the average person who wants to go and build something cool, put it on the internet, how do they protect themselves? And so that's some of the stuff that I'm really, really excited about.
Yeah, your passion is evident and infectious, and it's like me, I love it. Now, my third last question is to ask if you could please share a memory of your first personal computer.
My first personal computer was at school, because I was went to school in the UK, and we had BBC micros. And it was interesting because they boot into a programming language. They boot into BASIC, and you could write 10, print hello, my name is Simon, 20 go to 10, and most kids would do it, and it would fill the screen with the name, and they go like, okay, cool, hit escape, and then walk away. And for me, I looked at that and went like, I can make this do anything. And I think that's a common story that people have. And then later, my parents bought me an Atari ST, and I started writing games for it, and they were terrible, but I was so proud of them. And it was this sense of accomplishment, of this problem solving and like understanding how this machine worked. Probably says something really terrible about me, like a complete control freak or something like that, but it was this sense that I could take this thing and make it do pretty much whatever I want. And actually, I think that's what a lot of people are now, sorry to yank it back to AI, but like, I think that's what a lot of people are now finding about like kind of AI is they can have an idea and then they tell it what to do, and and they can get this idea out of their head and out into the world. And that's very cool. Like, without having to read hundreds of pages of like, this is how registers work and this is how you do stuff. Like, so I think that's very, very cool. But
it's the natural language user interface we've been promised by sci-fi for decades. We have it now.
Yeah, exactly. Yeah.
Just insanely good. So can you please share some of the best advice you've received in life to help you get where you are today?
I mean, I think one of the things was, somebody told me was, a lot of stuff is luck. Like startups are luck. It's really, really easy to have bad luck. I think it's something like 95% of startups fail. So just in the startup world, you have to get lucky just to survive. And part of that is avoiding bad luck. And part of that is embracing good luck. Good luck comes your way. You get an opportunity you never thought of. You happen to be sitting next to somebody in an airport, and they're like, actually, I do need that. And you can sort of work with them. He says, plucking an example completely randomly. What the best advice somebody told me was that luck is a big part of it, but you can change the way that luck affects you. You can give yourself more chances to have good luck.
You make your own luck.
I don't think you make your own luck, but you can give yourself more chances to get another go at you can give yourself more lottery tickets. Yeah. And there was a really interesting thing. A friend of mine years ago started a startup in the UK, and it suddenly got a lot of press. And a PR firm phoned him up, and they said, "How did you get? We're not trying to pitch you. We're just gobsmacked. How did you get such good press?" And he said it was really easy. And they were saying, "Okay, how do you do this?" And he's like, "I've been going to conferences for 10 years, and when I'm at a conference, even though I'm not naturally a sort of social person, I go to the thing and I go talk to everybody." And then I make a note of them, and then 6 months later, or whenever I think of something interesting, I email them and I keep in contact. And I've been doing that for 10 years. And then suddenly, when I launched my startup, I could just email all these people, and I kept contact with them. And in some ways, like, he had made his own luck. He'd increased his probability space. And that was the best thing, was like, some people are born, some people have the privilege of having a little more luck than others. Like, if you've got parents who support you, you can go do your own startup. Whereas if you're having to work your way through stuff, it's harder for you to go and, sort of do all the time that you would need to go and do a startup. So some people have more luck, but you can, a bit like poker. Like, poker is a game of luck, but it's also a game of skill. And you maximize when you have a good hand, and you minimize when you have a bad hand. And that's some of the best advice I got, was like, you're going to get unlucky sometimes. Brush yourself off. You're going to get lucky sometimes. Embrace it. Just try and give yourself more chances.
So, Simon, what is your final message to the Australian and global IT Wire audience?
I think my final sort of message would be, this is an incredibly exciting time. It's a very contradictory time. It's a very difficult time because I don't think anybody tells you they can predict and tell you what's going on 6 months from now, let alone 18 months, is trying to sell you something.
Yogi Berra famously said that predictions were very hard to make, especially about the future.
Exactly, 100%. That was the other bit of advice I was actually going to give. But it's definitely an exciting time, and there's an energy in the air. Are we going to have a complete financial collapse? I don't know. I mean, some signs point to yes, but like we're in very weird times. Like, is this going to change? Is everybody going to lay off every single programmer and like they're going to have one programmer that does everything? I don't think so. I think a lot of the layoffs have been more motivated by other reasons, and they've been hidden under the cover of AI. But that's just so that's just me. But I think things are changing, and when things are changing, it can be a nervous time, but it can be also a really good time for opportunity. And I think the fact that the startup scene and the tech scene in Australia is so vibrant and so experimental is probably the wrong word. But
necessity is the mother of invention, exactly. And we've got the what do you call it? The tyranny of distance.
Yeah, and they're so resourceful, kind of. I think Australia is really, really well placed to go and have this could be a really exciting time for technology in Australia.
Well, Simon Wistow, the co-founder and vice president of strategic initiatives at Fastly, it's been such a pleasure to speak with you today. I hope you had a great time at your conference today, and I look forward to speaking with you again in the future.
Happy to chat anytime. It's been great.
Thank you so much. Bye-bye.
Good.